Hi everybody, good to see you all again. So today we're going to be looking at the next major class of polyhedron known as the pyramid here. And you'll note that if you've gotten a copy of the handout, you can take a look at what's going on here. These are pyramids, these are not. So again, I'd like you to take a minute, pause the video here, and note what are things that are true about the pyramids that are not true about others here. So take a brief moment and figure out what they are. Okay, now that we're done, you can take a look. The first thing you can note is that these are significantly, for lack of a better term, they're pointier than the prisms. You'll notice that pretty much in every single one of these, there's an apex at the top, a point where everything converges, unlike the prism here. You'll note that unlike the prism, there's only one base here, and you can see that according to this is not a pyramid here because, as you can see, it's rounded. So it's in a way, it's kind of like it's another polyhedron here. So we can mention this sort of thing. So we note that in this situation, if we compare this to prisms here, we have a single base as opposed to two bases. We have a point on top, and then we have a bunch of lateral faces that are not rectangles or parallelograms anymore, but they're all triangles. So we can use that to define our pyramid here. So we can define a pyramid so first off, note that it's a polyhedron, so that discounts this here. So we can say a pyramid is a polyhedron with a single base and triangular lateral faces that converge at a single point. So you can see here, this is our setup here. The same idea is going to occur like this. You've got your bases here, you've got your triangular lateral faces, and they all come to a point up here. In general, what ends up happening is that this point, we refer to this as the apex of the pyramid here. So here we have a bunch of apexes or apices, I suppose, if that's the proper plural. I'm not really good with Latin, but you can see how these all work out here. Okay. You'll also note that much like prisms, we can differentiate pyramids based on their bases here. So we have a pentagonal pyramid, a hexagonal pyramid, triangular pyramid, a square pyramid here, things like that. And just like before, you can see that in this case, some of them look kind of slanted, like the second one here. You'll note that this one doesn't appear to be, right up and down here, kind of tilted. If you were to look at the center of the base and connect the apex to it, you'll note it's not perpendicular here, unlike the others like this. If we look at the centers of the bases here, all of these appear to be perpendicular. So just like before, we have our oblique here. So this will be an oblique, regular, hexagonal pyramid. And then you have your other things here. Here you have our regular pentagonal. So there's our regular pentagonal pyramid. And I'm sure you can figure out the rest here, so I'm going to leave it as such. Okay. Now, you'll note that for regular pyramids, things occur here. You'll note that we drew all these vertical lines here. These vertical lines are basically how tall the object is. So this here is basically the height of the pyramid from base to apex here. And in this case, for most pyramids like this, h is going to be our altitude or height. Now, the thing you're going to note here, on the other hand, is that L, on the other hand here, if you take a look at L is not perpendicular to the base. H is perpendicular to the base like this here, but L is not. L, as you can see, goes down to the side like this here. It goes down one of the triangles. It's as if we can just remove this face of the pyramid here, this triangular face, pull it aside, and we see the L is the altitude of that triangle here. So as a result, because of the way that's set up here, that's going to be a little bit different. We refer to this as what is known as the slant height here. So L is going to be the parameter I'm going to use for slant height here. In this situation, that's going to be the height of a lateral face. Now, note that one important thing about this here is that this is defined for regular pyramids only. I think you can convince yourself here intuitively that this L is going to change values if you have a pyramid that's not regular. So for instance, something like this here, I think you can see in this upper oblique pyramid here, right? You can see that the heights will be different because of the way that the pyramid is shaped. Furthermore, if the pyramid's base is not regular, let's say it's a rectangle with dimensions 2000 by 1, two of the lateral faces are going to be very, very far away from the center, whereas the other two are going to be much closer here because of the 2000 by 1 bit. So note that in this situation, it's only defined for regular pyramids, okay? And with that, we should be able to move on.